Okay. Let's do it. Sorry about that. Lab ran long across the hall. One of those long days for them. So let's pick up where we left off, right? So last time we left off, we're talking about hair. So we talked about the layers of hair. We talked about the medulla, the cortex, the cuticle, right? That's kind of like the hair shaft piece of it. That's what you see above the hairline, or kind of above the scalp line, if you will, coming out. And then of course, within that, in the hair bulb itself, then you're going to see some extra stuff, right? So you see some epithelial sheaths around it. So you see an internal and an external root sheath. In this particular case, they're calling them external external and internal root sheath. And of course you have the dermal, which is the connective tissue root sheath. So it's basically kind of surrounded by connective tissue. And that's what weaves with the dermal connective tissue to kind of get your root, your hair root, kind of woven into the dermis itself. Okay. And we also took a look at some of the structures that are in there. For instance, we made note of the melanocytes that are down there by the matrix area. So that's just like a stratum basal. So basically the same basic process that you would see with just normal keratinization. Same basic thing, only in this case, you're adding that color, the pigmentation, to the hair cells themselves, and that's what colors your hair. Okay, and then of course, obviously your hair cells die, just like your keratinized skin cells die. And then that's basically is what you end up cutting off, which is what I need to cut off because I'm getting a little long in the shag at the moment. It's driving me crazy, to be quite honest with you. So probably in the near future, usually March, I do this twice a year. It's my like sheep shearing phase, right? So I'll probably come in like almost bald at some point. So I'd be like, what in the world happened to you? It's like, it feels great. It's like, it feels wonderful. So that's how I'm going to lose. That's my strategy for losing weight. I could stand to lose a few pounds. Instead of actually doing it the hard way, I'm just going to cut off my hair and hope that that's, that'll do it. We'll see. I'll let you guys know if I get myself down to where I want to be. I know, not happening, but anyway, there it is. Okay, so let's take a look at color and muscle. So we talked a little bit about color, right? So just like we had melanin control with your epidermis, the same thing's happening here, right? So whatever your pigment is what's going to be deposited in your hair, right? So this is largely, obviously there's differences here, true? Because you see some fairly light-skinned individuals with some fairly dark hair. At least their hair is a lot darker than their skin, right? And so obviously there's some nuances here in terms of the rate of the deposition that you have. But ultimately what you're talking about here is not necessarily the type of melanin you're laying down in your hair, you're talking about quantity. So if you have a lot of brown, black in your skin color, then that's the hair color you're going to lay down. The difference is with hair color is you're going to lay down more. And this is the reason why your hair color is darker than your skin color, almost in all mammals. Right, so you kind of got that, if you got one of those dogs where you kind of have to groom them down and you kind of like can see the little pink skin showing through, even though they got like black fur or something like that. So that's obviously you have differences in the amount of pigment that gets laid down in there. And that's the reason why your hair color tends to be darker than your skin color. Okay. Muscles for the hair. So you have a couple of muscles in there. Smooth muscle, muscles that are associated obviously with that are near the surface, not actually part of the dermis itself, not actually part of the hair itself, but that's in kind of underneath those lower layers of superficial muscles, right? Those kind of like create some rippling. But really what causes a lot of problems in the dermis, not problems, good problems, right? Is the smooth muscle that's in there, which is the erector pilus muscle, right? The erector pili muscle is the one that's tethered actually to the hair itself. And this is the one that when it contracts, it shortens, and then it's going to cause that hair to basically swivel. So basically it's going to cause that hair to kind of pivot and stand on end. This is what causes your hair to rise, is the erector pili muscle. And there's, this is also oftentimes what causes goosebumps, right? So this is basically where you get such a strong contraction that it actually raises up that particular portion of the dermis so that you can actually see that rise as sort of like a little bump on your skin. Obviously, these are triggered by cold, right? So the idea of chills, so there's obviously some very strong regulatory relay connections to these particular muscles associated with your cold and warm, hot receptors in there. But it's also associated with your sympathetic system, your sympathetic division of your nervous system. We haven't gotten there yet, but anybody know what the sympathetic division does?
Chemical reactions.
It is chemical reactions, right? It's part of your nervous system. Exactly, right? It's part of your autonomic nervous system. So it's basically like non-voluntary. This is your fight or flight response. This is basically what kicks in when you're basically jumping out of an airplane, right? So that adrenaline rush, that's all sympathetic physiology. That's what that is. And so this particular division is actually what's responsible for making your hair stand on end. Think about it for a second. We're mammals. Most of the time, our hair doesn't stand on end, even when it's cold. When does our hair stand on end? When you're afraid or you're threatened, right? That, yeah, that would be, but that's an emotional response, right?
Yeah.
So, but
reaction.
it is, it's an emotional response, and the flight or fight is very much an emotional response, because basically your emotions, when you're acting and reacting emotionally, you're basically reacting instinctually. That's what's happening, because you don't understand the what and the why and the how. You just know that you have to duck, because if you don't, and it's like an overwhelming emotional impulse to duck, right? It's like, it's either a fear-driven response or just like, I have to duck, right? You don't know why that's your emotions doing that. That's like what instinct is about. You can't reason it out, right? If you reason it out, you're probably dead. That's probably what happens there, right? But the best example of this is moose, right? Now moose is pretty laid back, but I mean, like whenever you have a dog running around the backyard, like especially like at night, and they're, they got their little, their hood, right? Their little backyard area, that's theirs, right? But you have some sort of an animal run through there. And what happens to the dog? They're barking, but take a close look at the dog. What does it look like? The back of the neck, and where else? Yep, all the way down. It's like a little stripe, right? So you see a big old poof right there. I mean, when they're in like full yard defense mode, like this is my pack, like William is my pack, and I'm Moose and I'm taking you down, right? Then Moose has short hair, so it's a little harder maybe for Moose, but did his fur come up? Oh, wow, cool. Way to go, Moose. Way to protect the fam. But, right? So I guess that's his job, right? So he's but that's your hair standing on up, right? So generally speaking, when your hair stands on up, it essentially means that there is usually some sort of a fear response. Think about it. We've all walked into a room, haven't we? And we've like had this very deep, unsettled feeling, like something is like not right here. There's like something that I can't explain. It's a very fear-driven sort of a thing. Like, I need to get out of here because something bad's happening here. And I don't know what, and I don't know how I know that, but I can feel the hair standing up on the back of my neck, right? If you have hair on the back of your neck, right? But you can feel that energy throughout your body, right? You can feel, it's like all of a sudden, it's like you're doing basically the same thing the dog does. This is a mammal thing. Now, why does a dog's hair stand on end? Because it want to look fluffier? Exactly. That's exactly what you're doing, right? So basically what you're doing is you're posturing. This is, by the way, it's hilarious. Even males of the human species, as smart as we all are, you see them get into a fight. What do they start doing? Right? You see this? And it's so cute, right? Because they're like little, and you're like, you know, it's like if you're kind of already, if you're pretty comfortable with yourself in the situation, you're just sort of like, whatever, right? And if you're threatened by a situation, then you're going to go, what are you trying to do? You got nothing there, right? I mean, let's face it, right? I mean, you're all of about what, 5'2"? I mean, you're trying to make yourself look bigger. You're a mammal. You are in 100% dog mode. I mean, mammal mode. I mean, we are talking about howling at the moon mode. You know, it's true. We've seen our fair share of fights to know it's like, oh, you're such a mammal. You are such a mammal, right? Because what's the non-mammal response? Just use your brain, right? Dude's ready to swing. Fine. I'm ready to block, but I'm not going to swing back, right? So I'm not threatened here, right? So I can reason. It's like, dude, relax. Like, what's eating at you? I mean, this is like not something that's worth going to jail for, because I can guarantee you, if you make contact with me, that's where you're going. So no mercy at all. So I fight in different ways and more effective ways, assuming I survive. Right? But I mean, right, that's the thing. Right? Obviously, we've got one person in fight or flight mode, clearly feeling threatened. But the smart money, and this is where you get good at negotiating yourself out of conflict, is to realize, wait. Okay, first of all, we're getting ourselves worked up. Let's cool down. Let's talk. Let's reason with ourselves and figure out what's going on. Why are you so ticked off? I mean, you shouldn't be this ticked off. Okay, granted, you just had about, 6 pitchers of beer, so you're not really rational. But, I mean, are you really worried about that one anyway? It's like, swing away. You're not going to be able to hit me. Because, I mean, after 6 pitchers of beer, I'm surprised you're standing up. You're certainly not going to be able to have eye-hand coordination. So I'm not threatened at all, right? So more than likely, you'll probably take the right hook and you'll end up just falling into me, and I'll have to like carry you like to the nearest couch or something like that, right? So turn you over on your side so you don't choke on your own vomit. But anyway, yeah. See, that's what drinking was like for me, which is the reason why I'm not a party person, because I was always the one cleaning up. And trust me, parties have absolutely zero appeal when what you end up doing is driving a bunch of drunk people home and going through the car wash. If you're lucky, you might be going to like, getting your upholstery redone. You do that a couple of times, you're like, listen, you know what? Go have fun, because I'm going to stay here, and I would rather read tax code than to go out and party and be the designated driver.
Enjoy responsibly before wanting to read text.
Yeah, you got to have something in you and to enjoy tax code. But yeah, that's I'm not a party person for that reason. So let's take a look at some of the other accessory structures, right? So we got our hair piece, no pun intended, right? So we got our hair part done, right? So now what else is in there? Because there's a lot going on in the dermis, right? Not just hair. There's other stuff in there too. The glands. The glands are cool because you got a couple of glands in there and they're really big. They're good. They really want to understand them. So first of all is you have your sebaceous glands, right? These guys are a really big gland. They're associated with the hair. So here you can see your sebaceous gland right there, nestled right next to your rector pilus muscle. So you can see how it's tethered and connect it to the bottom of the hair, the bulb of the hair, right? So that it can make it stand on end when it contracts. But your sebaceous gland is basically a ducted gland that will basically be dumping sebum into the shaft, coating your hair as it grows past it. So what exactly is sebum? Well, sebum is basically like an oil. So this is like a lipid secretion that is kind of like your natural conditioner. So that's what that is. And because it's a lipid, the type of secretion that it does is not merocrine. It's going to be holocrine. Remember holocrine? That's the one where the cells self-destruct and then they just kind of like eviscerate themselves. They just kind of like ooze out all of their lipids, their sebum, and it coats your hair. Right. This is, by the way, like, you know, like over time, your hair gets greasy is because that's your sebum. That's your natural hair conditioner. That's in that. And of course, I mean, obviously you have many, many different types of hair textures and thicknesses and drynesses in particular. And so like the sebum effects is different. I mean, some people, you know, don't have to wash their hair, you know, for a while in between washings. Other people, man, they're having to wash their hair like twice a day, or they're turning into a grease mop, right? And so it depends. And part of that is the structure and the nature of the hair itself. Okay. So all of us who are into hair, we all know and suffer through those realities. So ideally what this is supposed to do is to kind of keep the integrity of your hair shaft. Because remember, your hair, as it's growing beyond your scalp, is exposed to the elements, especially in Denver, where it's very dry. And so those already dead cells run the risk of drying out, becoming brittle and flaky, right? And what does it look like when hair starts to flake and sort of start to lose its integrity? Well, that's scalp. That's actually scalp skin starting to shed. But for those of you who have long hair, you're always fighting split ends, right? So you see the ends are starting to split out and you're starting to lose that sort of cohesive integrity of the actual hair shaft itself. So it's drying out and basically becoming brittle and it's splitting. And so this is also supposed to be a little bit of an antibacterial as well. Well, generally speaking, bacteria don't really bother with this so much. I mean, it is easy to hide in there because you got a lot of hair. Maybe, but the idea is this is not a really good strategy for bacteria to access the body because it's like you can't get through this, right? I mean, you got scalp to get through, and there's just it's not very easy to get into the body from here. So, so ultimately, then these sebaceous glands will go into the hair follicle to coat your actual hair itself. With the exception, obviously, of some areas. So you don't have a lot of sebum production in your eyelids. You don't have a lot of sebum production in your lips, right? So that's because you don't need, it would be kind of cool, right? Because you would have like a natural Carmex.
Yeah.
So you would save money on the chapstick purchase, especially in Denver. I don't know about you, but I think I single-handedly pad the French Riviera estate for the CEO of Carmex. Because I basically have like a glucose drip hooked up to me full of Carmex. That's just my thing. That's right. So the genitalia also, you know, not a lot of sebum made there either, right? So, so that's just, you know, it's mostly in your scalp for the most part, right? I mean, that's really where it is. For the most part. So, and that's because of its exposure. So now what about the other gland? Sweat glands, right? You have two different types of sweat glands actually. And they're not all abundant in the same fashion. The first one is what's called the eccrine sweat gland. This is a merocrine type of strategy, right? So this is the one where this is kind of what you mostly associate with your sweat glands. So it's pretty much everywhere in your dermis, everywhere you sweat, of course, with the exception of palms and soles, like that's thick skin, so you don't sweat here for the most part. Sweaty palms. Excuse me, I went the opposite direction on that one. I was thinking like I was going one way and my brain like did a photo negative on me. So not that these are increased in these ones because of the sweaty palms thing. Psalms, there we go. So you have an increase of these, right? This is where you get the sweaty palms from. That's what I was trying to say. And my brain just did a just photo negative on me. Right, that's kind of where we get that. So basically when you're like, I can get you guys to sweat in your palms pretty easily by doing this. Take over the class.
I'll give it my best shot.
Right, so eventually it'll be like, okay, but then pretty soon what? And then I'll look for the face of terror. So Renee's very terrified look on her face. So then I'll give it to her, right? So then those palms will start sweating pretty quickly, right?
Yeah.
Your fear of public speaking kicks in, and then all of a sudden you're just like butterfingers, literally. Yeah, I'd be like, oh my gosh. Yeah, this is for your final grade. You do a great job, you've got an A, you're done with the semester. You do a poor job, you've got an F, you're also done with the semester. Right? So it's like, right. So that would get your palms, but that's a fight or flight response, right? So that's part of that whole sweating thing when you kind of get that nervous sweat going on. So it's kind of, you can see the sweating is really related to a lot of different pieces going on. So it's not just, oh, I'm just sweating because it's hot. Well, yeah, that's true, but we also sweat for other reasons as well, right? And those are actually the more interesting ones to me, personally, because everybody already knows you sweat when you get hot. Of course you do. I mean, you know, but sweating when you get stressed is a different creature, right? That's a different thing that you're doing there. So typically this is like a group of tubes, right? They're kind of coiled tubes. So you can kind of go back if you want and kind of look at those sort of organization of like, you know, the alveolar and the tubular and all that sort of stuff. But this is kind of like just a big bunch of tubular tubes that are all kind of bundled up together into a giant gland itself. And so what you see in the scalp slide is a cross section of that, those tubular systems. And then of course they open, they don't basically, they're not like sebum where they basically dump into the hair shaft and they go up. They actually have a duct that goes up to the pores and then they release in the pores. So they produce in the dermis, they release in the pores through a duct itself. And then ultimately it's releasing sweat. So what is actually in sweat? Well, sweat is mostly water. You do have some waste like nitrogenous waste, for instance. Also salts are in there. So there's a lot more than just water and sweat. It does cool you off, but it also basically is secretion, or it's excretion. So excretion, getting rid of waste, is also part of sweat. Right. And so you're obviously getting rid of salts, excess salts and things of that nature and nitrogenous waste, which is one of the reasons why the dog always likes to lick on you when you're sweating. Why? Because you're like a giant salt lick. You probably smell great, apparently, if you're a dog. I mean, I don't know. It's like, right? I mean, I don't know, where the dogs are weird and cute and wonderful and crazy and yeah, all in the same little furry package, right? That's why we love them so much, because they look like us, only with more fur. And a lot of times they act like us, only with more fur. So we see ourselves in our dogs, which is the reason why we love them so much, because at heart, we're all narcissists, right?
Hey. I like this word.
In its truest sense, right, where Narcissus actually fell in love with his own image. So if you see yourself in something, that's a Greek version of the narcissist term. So that's what I mean. Yeah, nice. So I don't know what you call that. That would be something else. That would be like, yeah, I don't know what that would be, some other Greek god or something like that, right? So, yeah, I like that one. I have to admit I'm totally down with that one too. I aspire to be like my dog, except for the barf eating. I'll pass on that one. So I'll let that one go. I'll be choosy about how, let's face it, I aspire to be like Moose. right? Because Moose is ultimately cool. So you've got a fan club, Moose. He's like, I'm just asleep, leave me alone. So the other big thing is not just waste, but also temperature regulation, right? So that's a big piece of it. And we'll talk a little bit about that a little bit later on, physiologically speaking. You also have another type of sweat gland, which is the apocrines. Apocrines are not as common and they're not as ubiquitous. These basically will only turn on at puberty, and it's only in limited areas. Unlike the eccrine sweat glands, which are the ones that cool you off, these ones will open up into hair follicles and kind of combine with your sebum. So you'll kind of, in these areas, you'll kind of get an apocrine sort of sebum gamish of secretions that comes out in the hair. Now, what's coming out of the apocrine glands is not the same as the eccrine glands, where it's mostly water and some nitrogenous waste and things like that. What's coming out of here is organic compounds. What does that mean? That means carbon-containing compounds, not like organically grown. But these are carbon-containing compounds. And for the most part, they don't have any color or odor to them. However, bacteria that hang out in this area will basically metabolize these compounds and create smelly byproducts. So where do we find these apocrine glands? Yeah. In the axillae, right? Which is what? Axillary, armpit, right? Your genitalia, right? Anus. So these are all the smelly areas, pretty much, right? And those are full of apocrines. Now, they're not involved in temperature. So let's, wait a minute. Okay, let's take a look at this. Great. So most of us, so there's entire industries of cosmetics that does battle with this one, right? I mean, the entire deodorant industry there is involved in this one. So you could, I mean, we spend most of our life battling these apocrine regions, right? Because we're trying to not overwhelm anybody with our presence, so to speak. I'm trying to say that politely. Right, so the question is why? Right, if we spend most of our adult life doing battle with this, then why? Well, think about it for a second. First of all, let's take a look at the pattern. Right, these guys don't turn on until when? Puberty. What also happens during puberty? That's so proud. I like that. Right, yeah. Basically, you are turning from a kid who can get away with taking a bath on occasion. Why? Well, it depends on what they're doing. But I mean, for the most part, a kid, they don't stink. They smell like a kid, right? But then once they hit puberty, then what? Dude, you got to shower like every day now because you are not living in this house if I have to smell that the entire day, right? One thing I noticed is that 7th grade girls are very blunt. So I learned quickly. I'm a quick learner, right? So I learned the hard way, right? But what is 7th grade? What's going on in 7th grade? What, you're all of about what, 12, 13 maybe, right? You've kind of crossed over from being a sweet smelling little kid to now being a rank stanky middle schooler, turning into a rank stanky teenager, right? Think about this for a second. Now I'm kind of picking on the stink, but why do you do that? Why does your body do that? Think about this for a second. Everybody, we spend a lot of time covering it up, but everybody has their own unique smell. Right? There's a couple things going on, right? There's what I call the mammal smell. It's like just the way you smell as a mammal. A lot of times, like when you're walking or running, and it's like you're not really sweating, but you kind of start to get that little kind of glow breakout, like right before you start sweating, and you kind of smell your little mammal smell. You know what I'm talking about? That's like a normal, like that's what humans smell like as mammals. But you notice that different people have different smells about them, don't you? So like one person will smell like like something, not bad. I'm not saying it's bad, right? I'm not talking about stink. I'm just like, just your smell profile, right? And another person will smell completely different. And it's not like a body odor thing. It's just kind of like their natural smell, the way they smell as a family. And some people have a very strong smell about them and some not so strong. Like I've had some friends where I'm like, I can actually follow you like down the hallway with like hours later because I can actually smell your mammal smell. I mean, I can actually figure out where you are, just like a dog tracking you down. Because it was that unique of a smell. We all have that, but that's on top of this. So when you go into like your body odor smell, right, which would be the apocrine, the untreated apocrine, that's also part of your natural mammal smell. Because if you think about it, right, not everybody's body odor smells the same. Just like every other mammal, their body odor doesn't all smell the same. This is the reason why mammals that are driven by smell can identify each other by smell. Because they walk into the room and they're like, oh yeah, Daisy's here. I can smell her, right? That's my big dog. Not quite as big as Moose, but she's the big one, right? So you can smell, because she's a hound dog. So hound dogs kind of have a little bit of a hound dog smell to them, right? So they can smell that Daisy's here. And we can do the same thing, only at a much lower degree. And that's basically what this is about. So the reason why, so a lot of times students will be like, well, why is this there if we spend so much time trying to defend ourselves from it, right? So trying to deodorant ourselves up and perfume ourselves up and bathe it away and all that sort of stuff. So why is it there in the first place? Well, the reason it's there is because we're mammals. And originally, the way mammals identify each other is by smell. So I know that you are mine because of the way you smell. By the way, you're not so far removed from the mammal stock. Think about it. How many of you guys, be honest, are clothes sniffers? Oh yeah. No. You want to say if it's dirty or not. That's not it.
No.
Is it? Because you can actually, like, let's say it's like, well, I don't know if it's really all that dirty or not, but you can have two different members of the family and they smell differently to you. So you can smell one, like, oh no, that's Kaylee's shirt. That's Lily's. I can smell Lily. Right? Those are the two girls. Right? So that's because you can smell that person. And that triggers a whole lot of in our brain. Just like mammal. It's not even human, it's all mammal. And that's all part of this. So that kind of sense of like, okay, that's my family smell. It's also can be very pronounced between mates. Where like a husband and a wife, they'll actually like, that's, they'll smell each other. And it's like, okay, that's my smell, right? So that's the reason why this is here. That's where this comes from, is because of that. So even though we do battle against it, it's how we actually identify each other. And we've seen this, haven't we? We've walked into a restaurant perhaps, and maybe there's, somebody who's a little ripe and you can smell them, right? But it's a very different smell perhaps than somebody else, right? So you can actually, by the way their body odor smells, you can actually, if you had to, you can like line people up and pinpoint them. It's like, well, this one smells like this, and this one, I can't explain it, but I can pick it out. It's like, oh, well, that's your smell, right? And so that's basically what all this comes from. So
The aversion to the smell, like, is that just purely conditioned over, like, for humans, like over a ton of time, or because it doesn't make sense for there to be a biological aversion if it's meant for purely like identification?
no, there is though. Because if you think about it, right? I mean, part of the aversion of it, right? You walk in and there's some people you'll smell their smell and you're like, that's not so bad. right? And then there's others, you walk in, you're like, oh my gosh, my nose is on fire, right? I mean, I literally feel like I'm breathing flames. It's like so sharp, right? My lungs, my respiratory system is like shutting down. My lungs are seizing up. My diaphragm is in like paralysis. And I'm like, right? We've all been there. But what that is an instinctual alignment, because smell goes into, for mammals, mate selection. So the idea is you grow up with a certain smell and identifying with certain smells, and some you like and some not so much. But in mammals, that smell response is what drives you away from your own family and to outbreed with others, to make sure that you're not inbreeding and creating genetic instability. So like people who are like, you know what, it sounds weird, but you have a great body smell, right? A great mammal smell. That's, by the way, worst pickup line ever. Don't try that one, right? So your mammal smell is right there, right? So that's a great way to get yourself pepper sprayed. Yes, you'd have to be another A&P nerd, right? But that whole idea, that, you know, like there's some just like mammal scents that are like, wow, you know, that's, you know, it's a positive response. Not like, oh, wow, that's like perfume, but it's like, okay. And others are like, ooh, that's a little overwhelming, right? That's kind of like a negative for you. But those types of negative positive interactions is what drives mammals to mate select in productive ways and keep them from mating with their own siblings, for instance, and crossbreeding and things like that. But
outside of this mating thing, and we've been conditioned from the time we were little seed pods to, we have aversion to smell, you know, take once kids to the zoo, you know what I'm talking about.
yeah,
But, doesn't what a person smell like has something to do with like their mental state, their state of health?
sure.
You can actually smell it when
Yeah.
somebody is like mentally in crisis because it has its own.
Absolutely.
order.
No, we emit things that we don't even realize. You know why? We know that we can train dogs to do it.
Yeah.
Like we can train a dog to know, to detect when a diabetic is out of adjustment. We can train a dog to smell the presence of cancer. Now, can we smell it? No. Right? But we're emitting something different that the dog can key in on.
You might not smell the cancer, but you can definitely smell the mental health.
Yeah.
No, I'm serious.
Yeah. Yeah, so I mean, like we're emitting things that we're not even aware of because we're not sensitive to that, but other animals are. Dogs are perfect examples, right? That's a plug for the service dog. So, because that's what you can train service dogs to do that. So, other types of glands. So ceruminous glands. So these ones are also, these are like sweat glands, the eccrines type of sweat glands, but they've been modified a little bit. And they're only going to be found in the external auditory canal, which is where? Yeah, your ear canal, right? This is earwax. That's what this is. Yeah, cerumen is basically earwax. And so it's got a little bit of sebum in there and a little bit of a couple of other lipids in it, a little bit more waxy and a little more substantial than just the basic sebum itself. And so basically what they're trying to do is just kind of prevent stuff from getting in there, right? I mean, like bugs and coating your ear hair in there, kind of keeping stuff out of there, because you don't want some bug crawling in your ear. That'd be a bad thing, like a mason bee, right? That would be a bad idea, because your external auditory canal is actually very similar to like a mason bee habitat, which is just basically like a little canal, like a little tube that'll just crawl in there and then do its little thing and like live its little life in there. And you don't want to do that in your ear, right? Because it's like, that'd be weird. And then of course, mammary glands, which are just purely for milk production. So these are modifications of the apocrine type of sweat gland. Okay, so that's where the mammary glands come from. And of course, these are all limited, right? These are limited in terms of tissue, which is the reason why they kind of are in the other glands category, because they're not everywhere. They're only just very specific areas. Okay. So what about another accessory? How about nails? Nails are very easy to understand because they're basically an extension of the epidermis. You'll notice the same theme here. Once you lay down that epidermis, right, the strata of the epidermis, then everything else is just a modification of that basic pattern. Okay, so let's just take a look at the nails specifically. So you got a couple of other areas of the nail that are common, right? For instance, the part that we cut is referred to as the free edge, and then of course below that is your nail body, and then at the bottom, your lunula is going to be that little soft spot that really hurts when you hammer on it, because that's basically where the new nail is coming out. So underneath that, you've got your cuticle, and then the root of the nail, which is underneath the skin. So underneath the skin, that's right there at the bottom of the root, is where the actual nail bed is, and that's where the new nail is being formed. And it's basically the same process, by the way, as the skin. So it's a keratinization process. The only difference is it's laid down flat. So it's the same idea as the hair. You're filling it full of keratin, and it's dying, it's dead tissue, and it just grows out in kind of a flat sheet in this particular case. So you're doing the exact same process as keratinization. So here you can see there's a couple of terms that you want to be aware of. So first of all, the so-called eponychium is the fancy word for the cuticle. And so this is going to be the part that's above the nail body. So notice it said the corneum, as in stratum corneum. So this is a stratum corneum layer, that dead layer that's full of keratin that's laid on top of the nail body itself. The hyponychium then is going to be below the free edge. So this is where your quick is. So where the skin meets the nail. Okay, this is where you shove the bamboo shoots if you're doing the traditional bamboo shoot torture, right? That's brutal, right? AMP is not for the faint of heart. Right, so, and then of course you have your matrix, which is deep down into the nail bed itself. So here you can see, stay up there. So here you can see your cuticle resting on top of that kind of eponychium area. So there's that stratum corneum right there. And that's laying on top of the nail matrix, which is where this new layer is being produced. Now notice the wrap around here. This right here is your epidermis. Notice how it wraps around and goes all the way around here. So your stratum basale now is right underneath your nail bed. And so all your stratum basale has to do is make new cells. And when it treadmills up, the corneum, instead of just being dead skin, completely keratinizes into hard nail tissue. So you can see how basically all you have is just a slight modification of your epidermal layers. And you kind of give it a little bit of a wrinkle right here where you kind of get this sort of over shift on top of it. And you kind of like basically kind of continue on with your skin. So what you do is you kind of do like a little bit of a fold over. So you kind of take it, you kind of bend it around, you kind of do a little bit of a fold over, and you kind of continue it on. So you have this little fold over part of your cuticle. And then you basically have your nail bed underneath that little fold. And so that's basically how you grow new nail, is you basically grow it at this particular point. So you can see how you have stratum basale wrapped around the entire nail bed here. So basically you can add cells in that direction. And that's what pushes the nail out from underneath the cuticle and into your lunula, right? Or the moon. So ultimately then, unlike hair, which kind of has this shedding cycle, right? Growth and shedding, nails are continuous, right? We all know that, right? Because we have to keep cutting them. And but it's also good too, right? Because if we rip a nail, then not a big problem. Just wait and it'll grow itself out and fix itself, right? So it's kind of it, assuming you can stand the pain from having your nail ripped off. So that's basically how that works. This is kind of like just this is a trivia thing, right? So there's no way this is going to make it on an exam, right? But this kind of gives you an idea of kind of what you're looking at, right? Fingernails typically are faster than toenails, right? So if you're wondering how long it takes, and this is variable, right? Because some people's nails grow really quick and some not so much. So that's the reason why there's a bit of a range, 0.5 to 1.5 millimeters a day, which actually is you can see that, right? Because when you kind of get a rip and it's kind of down to the quick and it hurts a little bit, it only takes maybe about a day-ish or so for it to kind of get beyond that and it starts to feel better, right? Because all of a sudden now you kind of like grown beyond that. And so if you can stand the pain for a day, you're good. And that's a little faster than toenails. And so that's the skinny on nails itself. Okay, so what about the physiology of this, right? Because that's the structure of it. So we got the epidermis, dermis, hypodermis, our subcutaneous area, and then we've got all of the accessory stuff in it, especially the dermis in particular, right? So great, that's nice, but what about its job, right? What about what it does for a living? Some of these we already know about, right? These are not, protection, clearly, obviously, right? This is a big one. So we can protect against abrasion. You rub on your skin, it's going to protect you, right? What happens if your skin's not there and you rub on it? You're rubbing on muscle or blood vessels. Bad idea, right? So that's a very bad idea. So because of this, because of its wear and tear and that abrasiveness, then you're obviously going to be rubbing off cells. So you're shedding everywhere all the time. So it has to be replaced all the time. It's also going to protect you against microorganisms, right? So they basically can't get in. So if they can't get in, then you're protected from those microorganisms. If all you have is exposed muscle, bacteria, free entrance, right? So that's a big thing. Also, the glandular secretions we mentioned have some sort of antibacterial properties to them, right? As well. Melanin, this is a big one, right? This is your protection against UV damage. And what does UV radiation do to you? This is your protection against DNA mutation due to UV radiation, right? Hello, melanin. I'm looking at you. Or melanin. Hello, melanoma, right? That's what we're talking about here. So your melanin is designed to protect you. Essentially, it's your natural sunscreen to protect you from DNA mutation in the worst way. Obviously, it's an insulator. Those of us who have long hair know what an insulator it is, right? Even if we don't have super long hair, when we get a haircut, we realize it's like, whoa, my head's a lot colder than it used to be, right? If you have long hair, you can kind of cover up your ears. You got like a natural ear muff there, right? If you don't have that long hair, you're screwed. I mean, your ears are falling off from frostbite. So that's a thing, right? Eyebrows, that's an interesting one. Have you ever wondered why your eyebrows are there? Yeah, right. So keep it from looking weird, right? We got pencils for that. But anyway, right? but the idea is, and that's true, right? Because I mean, we've all seen it, right? We've seen like unibrow, where you got like a full-on hedge that goes all the way across the face, and we've seen some people where it's like the eyebrows are just very slight, right? So there's a lot of variation in the eyebrows. But what are the eyebrows doing in there in the first place? Are they keeping you warm? No, it's not like my eyes are getting warmer there, right? So it's not that, right? What are they doing? Yeah, right? If you've ever sweat a lot, then your eyebrows are actually kind of breaking some of that sweat as it's rolling off your head. Now, it's obviously not perfect because it makes its way through there anyway, but it gives you a little bit of chance, doesn't it, right? Because as soon as you feel like your eyebrows, what do? Yeah, you like just wipe it off, right? So it's like your natural headband, but there's actually something a little bit more. I would also put eyebrows in the same category as eyelashes, right? Because you're protecting your eyes. Your eyelashes are there to protect your eyes from stuff, dust and things of that nature that can basically get into your eyes. So they get caught up in your eyelashes instead of going directly into your eyes. By the way, same thing with the eyebrows, right? So your eyebrows, if you kind of bushy eyebrows, you can kind of squint down and your eyebrows are going to catch whatever's coming at your face. It's going to get caught in your eyebrows and your eyelashes instead of in your eyes. So your eyebrows can work along with your eyelashes as sort of a way to sort of protect particles from getting into your eyes. So it's very protective in that nature. Of course, we have hair other places, right? So the old hairy nose thing, right? And then of course, ear hair, all of which, by the way, gets much more impressive the older you get. Because we've always seen the older dude, the guys especially, right? Because I mean, just like, you know, the eyebrows that were tame when they were young are just now just wiry caterpillars like Martin Scorsese on their face. They got ear hair coming out all over the place. I mean, they've got almost a full-on, you know, facial feature of nose hair just kind of streaming out of their nose. They need conditioner for it. I mean, it's just like hair coming everywhere, right? And so that's part of this. And oftentimes the question always comes up is like, well, why? Right? Why isn't it when you're 20? Why don't you have like all this ear hair coming out of your ear? And why don't you have all these like really thick, bushy eyebrows? Why does it seem to hit you as you get older and not when you're younger? It hits some people when you're younger too, right? Right. Like, why does the nose hair thing get so much more aggressive, like as you get older and things like that? I don't know. But one of the possible features is think about what it's there to do. Right? Your ear hair is there to protect your ears from things coming into your ears. Nose, same thing, right? Because that's your respiratory system. Eyebrows, same thing. It's to protect your eyes. But guess what and normally when you're 20, you're kind of flinchy, aren't you? Like if I threw something at you, you'd be like, right? When you're 70, if I threw something at you, you'd be like, right? Yeah. So your reflexes aren't so great. So what happens is you kind of start to add a little bit there. It's like, okay, I understand it. You're probably not going to blink fast enough now that you're 70. So I'm going to add a few extra caterpillars on your face to kind of give you a bit of a shot there, right? You're probably not going to flinch enough to keep that moth out of your ears. So I'm going to give you this big old bush of ear hair there to kind of help you out a little bit. So your reflexes aren't as good as they used to be. So I'm going to basically cover you in a fur coat so that you can kind of, you know, not have to rely on your reflexes because you're not as fast as you used to be. Okay. So that was my performance art for the day. I've got more. Nails, what are those for? Think about it. Our nails are pathetic, aren't they? I mean, look at a dog. What can they do with their nails? I mean, aren't they digging holes? I mean, it's impressive, right? I mean, they could dig all sorts of stuff. I mean, you know, some like a bear, they could kill you with those nails. I mean, they're like 6 inches long. They're like knives, you know? I mean, they got claws. Cats, there's a good one, right? Not quite like a bear, but they can still kill you. I mean, their claws are evil, right? I mean, they can slice you up and you enjoy it. It's like, aren't you cute? I'm hemorrhaging, right? I've got 911 on the other line, but you're just so cute, right? Right? So they're confusing that way, but yeah, that's okay. So I'm a dog person, so that wouldn't thrill me either. But you know, like, I mean, if a dog gouged me with their claws, which they've done before, it's like, yeah, that hurts, but I mean, you're cute, right? So because you were jumping on me to get a hug. So yeah, I'll try to like keep breathing while I give you a hug, and then I'll go and put a stitch in there too. But right, but our claws are pathetic, aren't they? Can we do much with them? Can we dig a hole with them? Can we do anything with them? Yeah, they're good back scratches. Not even that, right? Because you can't even get back there. It's like you don't have the joints for that one, right? What? You go, yes, okay, you're cheating. That's cheating. So most of the rest of us can't do that. Right, so this is supposed to be self-defense, but think about it. It's not really self-defense, is it? Right, so it's pretty puny. I mean, if you've got long nails and you try to self-defend yourself, what's going to happen to your nail before you actually do any significant damage? It's going to break off. It's going to be like, darn it. Now I've got like smooth nubbies, and now I got to figure out how to put this guy's eye out, right? Without like, anything sharp to my disposal. So then it gets interesting. So technically speaking, that's what they're there for. So we realize they're useless. So what do? We paint them, right? That's what we do. That's about all we can do, to be quite honest with you. They're pretty pathetic. We're pretty unimpressive as a mammal. If you lined us up in the mammal pantheon, everybody would laugh at us. We were like, wow, really? I mean, look, you're slow, you're small, you have no claws, your teeth are blunt. So why am I afraid of you? By the way, we are the dominant mammal on the earth. Why are we? What's our ace in the pocket? That's it. This is it. We have nothing going for us as a mammal, literally nothing. We're slow. We have no teeth. We have no claws, right? We're not very good fighters. We're small. None of that works in our favor. Almost every other animal has something to go with that. We don't have any of them. The one thing we have that nobody else has. Yep. We may not be able to win a fight. Yeah, right. We may not be able to win a fight, but we can think ourselves out of it, right? Every other animal, that's not the case. Then, of course, it can act as a diffusion barrier, right? So if it rains, it's not going to soak into you and blow you up like a water balloon because you got water, right? You got a water barrier. It's going to protect you. Never thought about that one, did you? Okay, so I'm already a little over time again. I get all excited. See, you guys get me all like revved up about all this stuff. It's exciting, and then it's like I lose track of time. Okay, so I'll start there. We'll talk a little bit about now some of the other things, which I think are actually some of the more important things of the function of the integumental system. And that kind of leads more into our physiology, which is actually perfect because as we start to segue in the next couple of slides, we're going to start moving toward more physiological themes as opposed to structural things. We'll stay structural in lab, but we're gonna start moving physiological in lectures. That make sense? Okay, that's that. I just have too much fun with you guys. That's what it is.